This lesson is about proving triangles are similar. There are 3 different ways to prove triangles are similar, and what we're going to be doing to prove the triangles are similar is kind of like what you did when you proved triangles were congruent. When we proved triangles were congruent, we used side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. This time we have only 3 to choose from. The first one is angle-angle similarity postulate. The angle-angle similarity postulate states that if 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. So here you see angle A congruent to angle D, and angle B congruent to angle E. So if we know that that's true, then we know that these triangles are similar. So I can write the following statement. Triangle ABC is similar to triangle DEF. So let's take a look at this problem right here. We are given that PT is parallel to SR. So I'm going to go ahead and write that on the picture. PT is parallel to SR. And what we want to do is prove that triangle PTQ is similar to triangle RSQ. Okay? So what we've learned before about parallel lines, and remember the mantra that I've always said is if you're given parallel lines, always look for congruent angles. So these parallel lines can tell me that S is congruent to T, and also R is congruent to P. And if you remember the reason why, those are alternate interior angles of the 2 parallel lines here and here. We also know that this angle here, PQT, is congruent to this angle here, SQR. So we actually have way more information than we need to prove that these triangles are similar. We know one angle is similar to or congruent to this angle. We know this angle is congruent to this angle, and we know that the 2 angles here are congruent by vertical angles. So we actually only need 2 of them because remember our plan is in this case going to be angle-angle similarity. So that's what we're going to use. So now I'm ready to write my proof. I've gone ahead and written the 2 columns there, and I've done the first step, which is my given statement. And now from my given, I know that angle P is congruent to angle R, and angle T is congruent to angle S. Now my reason for that is because of my given statement, and remember these are alternate interior angles, and so I'm just going to write alternate interior angles, and that is good for why those 2 angles are congruent. Okay, you'll notice that I have an angle here, so I can go ahead and cross that off my plan. I've got another angle here, so I can go ahead and cross that off my plan. So as you can see, my plan is actually complete. I'm finished with my plan. So now I can go straight to what I want to prove. And remember, what you want to prove is always the proof statement. Your proof statement always goes last. So what I want to prove is triangle PTQ is congruent to triangle RSQ. And my reason is always going to be my plan. So my reason in this case is angle-angle similarity. So there we've done it. We've just proven that the 2 triangles are similar by angle-angle. So my second way to prove that triangles are similar is the side-side-side similarity theorem, and we're going to shorten that by just SSS. Now it's really important that you do write that similar symbol here because we don't want to confuse it with the SSS congruence theorem that we've learned in the past. Okay, so the side-side-side similarity theorem says that if 3 sides of one triangle are proportional to 3 sides of another triangle, then the triangles are similar. So here I have a picture of 2 triangles that look similar, and so what the proportional statement means is AB over DE must equal BC over EF, which must equal AC over DF. So if we know that all these three things are true, then we can write the similarity statement triangle ABC similar to triangle DEF. Okay, so here we have a problem where we need to verify that the triangles are similar. So as you can see, I have two triangles here. I have PQR and I have this triangle here, PRS. And you'll notice that I have 4 and 4. Those are two smaller sides. And on this triangle here, which is the bigger triangle, 6 and 6 are the smaller sides. So sometimes it's helpful to separate these triangles out. So I've separated the triangles out a little bit so it's easier to see. And we have a 4 and a 6 and a 4 and a 6. So these two are proportional and these two are proportional. And then the larger side here, 6 and 9, will be proportional to each other as well. So if I set up my first proportion of PQ over PR, which equals 4 over 6, and then I reduce that, I get 2/3. My second set of sides here, QR and RS, also equal 4 over 6, which also reduce to 2/3. And my third set is PR and PS, which is 6 over 9, which also reduces to 2/3. So as you can tell, we have all three of these are equal to each other, which means that the side lengths are indeed proportional. So we can say, therefore, the triangle PQR is similar to triangle PRS, and my reason is side, 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 because all three of the sides are proportional to one another. And lastly, we have Sideangleside similarity theorem, abbreviated by SAS. So the Sideangleside theorem says that if two sides of one triangle are proportional to two sides of another triangle, and their included angles are congruent, then the triangles are similar. So triangle ABC would be similar to triangle DEF. Okay, so here we have a problem, and so what I need to prove is that the two triangles here and here are similar to each other. And I'm given that CD is 3 times the length of AC and CE is 3 times the length of BC. I also know that the vertical angles are congruent here and here. So as you can see, I'm going to be using side, side, side similarity because I have side angle, I'm sorry, I'm wrong. I'm going to be using Sideangleside similarity because I have a side and then I have an angle and I have a side, Sideangleside. So I'm going to go ahead and write the first statement of my proof, which is my given. And I'm just going to divide AC on both sides and get CD over AC equals 3. Divide BC on both sides and get CE over BC also equals 3. And all I did is division property there. And so if they both equal 3, that means that they're equal to each other. So that's my transitive property. So as you can see, these are my two sides here and here. So I can go ahead and cross those off my plan. Now I just have my angle that I need to do, which is the vertical angles in between. So there I have my vertical angles are congruent by vertical angles. And as you can see, this is my angle here, and so I can cross that off my plan, and I am now finished with my plan, which means I can go straight to what I want to prove in the last statement. And my reason for my last statement is always my plan. Okay? Thanks for watching.